Okay, last lesson, our introduction to differentiation. We learned that the derivative is the gradient. And if we can draw a tangent to our curve and use rise over run, we can find the gradient at certain points along the curve. However, it's not ideal because it is hard to make sure that you have drawn a perfect tangent, especially if you're drawing the graphs yourself and they're not done on beautiful grid paper like the ones that we had on the board were. So we want more precise ways of being able to find the gradient. What we're doing today is the introduction on how to differentiate algebraically. It is called differentiating from first principles. This is where it comes from, okay? This is the way they derived how to do this algebraically. There is a shorter method, which I will also be teaching you after this lesson, but there will be certain questions in tests and exams that could require you to use the first principles formula. So you do need to be familiar with this one as well, which is the long way, unfortunately. Okay, so this diagram is where we begin. This is how we explain where the formula comes from. We have a curve there. And if I want to find the gradient at a point on that curve, I'm going to choose this point here, P. That's the point on my curve. I want to know the gradient. Now, yesterday we were doing tangents, but this is another approach. What I'm going to do is choose a second point on that curve. So you can see the point Q up here, and I am drawing a secant. Fancy word, remember secant is the line that goes through the curves, which I'm going to be able to find the gradient of. Now, my point P has an x value of x, and when I substitute in, I would get a y value of f of x. I'm just saying f of x, x value, right? Makes sense, okay? The point Q is going to be a space of h away. I'm just going h distance along that x-axis, so that I'm now going to be at x plus h, right? That's my new x value. I've gone h further up the x-axis, so it's x plus h. That means if I was to substitute x plus h into my function, it would be f of x plus h for the y value. Still following? Great. So what I'm going to do is I'm going to find the gradient of that secant. Now, gradient, as we know, is rise over run, or remember that we also have our 2-point formula. y2 take y1 over x2 take x1. In other words, you subtract the y values for the top. Now, my y values, they look a little bit unusual, but my y values are f of x plus h, and then I want to take away the f of x. So that is what comes on the top of my fraction. That's my rise. The run is subtracting my x values. So here's my x values. It is that one, take away that one. X plus h, take away the x, which is how we get the bottom. Now for the final line in that little section there, the numerator hasn't changed because unfortunately I can't simplify anything in there. But on the bottom, x plus h minus x, the x's are going to cancel out. And all that's going to be left is the h on the bottom. Okay? That is almost the first principles formula. Almost. Now the problem is that that secant is not a perfect tangent, is it? Okay? I've taken 2 points on that curve and I've found the gradient, but it's not actually the gradient at x, okay? My gradient would be probably slightly down here, which is the other line that you have on there. You have a line down here. That's the gradient that I want, okay? So what we need to do is we need to introduce a limit. H, remember, is the distance between these x values here. If I introduce a limit where I say h is approaching 0, I want the space between x and x plus h to be pretty much 0. I want the space between, I want them right next to each other. then that means I'm basically at 1 point because there's 0 space between them. Yeah? I'm messing with your brain yet? So we are going to take this formula here, this rise over run that we found, and I'm going to introduce a limit as h is approaching 0 of that very same fraction that we worked out for the gradient. Because if h is approaching 0, it means those 2 points, the p and the q, are right on top of each other, and I am just finding the gradient at p. Okay, so that one there, this bottom formula, you can put a big box around it if you want to. That is the formula for differentiating from first principles. And you'll see the notation in there. You've got the f dash x, so that means I'm finding the gradient. And there's a limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so here is a question. I want to differentiate this from first principles. Now, I know this is a little bit painful because remember that the derivative is just the gradient, and everybody can tell me already what the gradient of that is. 2. We already know the answer. Who said 3? Right. Okay. The gradient, we know if that's a straight line, we know the gradient is 2. But we're new to this first principle stuff, so we want to start with an easy question and show you how to use this formula. Now, I prefer to work out, remember that formula back here, we need to know what f of x is. I already know that, given that in the question. But in the formula, I also need to know what this f of x plus h is. I like to work that out first before I try and sub stuff into my formula, okay? So I'm going to start with that part. What is f of x plus h? Now, we've done some functions before. That just means that everywhere where there is an x, I have to replace it with x plus h. So it's going to be 2. Instead of the x, it will be x plus h, and then close bracket, plus the 3. Okay? So I'm going to expand that. That's 2x plus 2h plus 3. Okay, it's just good to have that one first. Okay, here is my first principles formula. The derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that's just the formula that we just discovered. So we leave the limit out the front. That is always the very last thing you do. It's just going to sit there for a little while I work out what is happening with that fraction. So f of x plus h, I worked that out first. That was this 2x plus 2h plus 3. Then I have to minus f of x. That's the original function. Be careful. You have to subtract every term. So it's going to be minus 2x and minus 3. If you want to, you can put brackets there and expand the minus through, but it changes the sign of every term in that function because the minus goes through all of them. Okay? That is all over h. Now, there will always be some cancelling that will happen on the top of that fraction. You will see that I have 2x minus 2x. Okay, they cancel out. And I also have a 3 and a minus 3. Here's a little tip. Everything in your f of x, so the f of x, which is my 2x, this 2x plus 3 part here, that whole function should always cancel off. Okay? I want to write down what is left. I have a limit still sitting out the front as h approaches 0, and I have 2h on the top, that's all that's left, and a h on the bottom. Okay, now, if I have a h on the top and a h on the bottom, they just cancel out, and all that's left is that 2. I actually don't even need the limit. Normally, for a harder question, we actually have to sub in that limit at this stage, but we don't even need to do that. There's no h's left to sub into. The answer is simply going to be 2, which we knew. And we had to go through all that process because the question said I had to use first principles. All right, let's do a slightly harder one on the next page. So here is a new function, f of x equals 2x squared plus 5x minus 4. We're going to differentiate it using first principles. So like last time, I know I need to find out what that f of x plus h is. So I'm going to need to sub that into my formula. Everywhere where there is an x, you put x plus h. So it will be 2 bracket x plus h squared plus 5 bracket x plus h and then minus 4. Expand everything out and simplify it. This is why I like to do this first, because otherwise you're rewriting that limit fraction over and over and over again while you're trying to simplify this f of x plus h. So expanding the brackets, the squared, the x plus h squared, using the short method, x times x is x squared. X times h doubled will be 2xh. Don't forget the middle terms. Then h times h is h squared. Okay, I can expand the next bracket. That will be 5x plus 5h minus 4. Still not completely expanded, so let's go the next line, expand further. 2x squared plus 4xh plus 2h squared, and then all the rest of the stuff that's already expanded out. Okay, so we've got our f of x plus h. We're ready to go with our first principles formula. Let's write it down again because I want you to memorize it. So f dash x, which means derivative, limit as h approaches 0, f of x plus h minus f of x all over h. Okay, sub into that formula. So the limit is going to stay out the front. F of x plus h, that is that big thing that I just expanded. The 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 4. Then the formula says minus f of x. That's my original function, and remember to expand the minus the whole way through it. So it will be minus 2x squared minus 5x and plus 4. Every sign changes. All over h. Okay, remember now we want to cancel, and everything in that f of x should cancel out. So it's 2x squared minus 2x squared, they're gone. I have a plus 5x and a minus 5x and a minus 4 and a plus 4. Everything does cancel out from that f of x as expected. Okay, let's write down what is left. Limit as h approaches 0. I have 4xh plus 2h squared plus 5h all over h. Now, at this stage, you should always be able to cancel off that h on the bottom. Because this one has 3 terms on the top, I need to factorize out a h first, so I can do that. So let's factorize. Limit as h approaches 0, bringing a h out the front, I will get 4x plus 2h plus 5 all over h. Okay, and then h on the top, h on the bottom, the denominator, they're cancelled out. Okay, so this is kind of where we were at last time, but this time I still have a h left in my equation there. So this is where the limit part comes in. The limit, remember, is h is approaching 0, which means that you sub into the equation now that h is 0. But you only do it at the very end. Don't ever try and do it early on. The very end, once everything else is cancelled out, we sub in that h is 0. So it will be 4x plus 2 times 0 plus 5. So 2 times 0 is obviously 0. It's not going to do anything. And I will just get 4x plus 5 as my derivative. And you may have been expecting something like that because that was a parabola. And we did do a parabola yesterday graphically, and when we differentiated, it became a straight line. And so here it is again. We had a parabola, and there is an equation of a straight line. The other thing that you will notice is that once I sub in h is equal to 0, don't write the limit anymore. That's where the limit has been used. You don't write it anymore. But you must, for all these other steps, you can't just leave the limit out. Sometimes it gets forgotten, and whoop, the limit magically appears. Okay, you have to write limit the whole way down until you have subbed in that h is equal to 0. Okay, so we're going to be doing